Hello everybody. We have the next three mechanisms we're going to learn about. The first one you can see in front of us is the rack and pinion. Rack and pinion is made up of two parts. The first part is this right here. This is a pinion gear and this is a rack gear. All right. We have four questions for you. The first one is, what is the type of input movement? And there's three choices for you to choose from: rotary, reciprocating, or linear. Now, when I turn this, this is the input. The handle's attached to the input. So what type of motion is the pinion gear? Second question, what is the type of output movement? The rack is the output movement. Now, once again, they've given us three choices: rotary, reciprocating, or linear. When I turn this input, the output moves in one direction. So when you answer this question, I want you to think about this. If you went through and you did the last group of questions on the video, we saw the cam and follower. The follower, we said, was reciprocating movement. One turn of the handle, it went in both directions. This time, we turn the handle around once, and it goes in one direction. Okay, so use that to help you figure out the output motion. Next question after that, if the diameter of the pinion gear, which is this part right here, were increased, which means we make the gear bigger around, what would the rack move? So if we made this bigger, how would this move? Would it go a shorter distance or a longer distance? If we turn the handle around one time, we have a bigger gear right here. Is that going to move more teeth on the rack gear or less teeth on the rack gear? And the last one is the direction of travel reversible. So if we push on the rack, does the input move? All right. Okay, that's our first one. The second one we're going to work on is the chain drive. And the chain drive is something you guys are probably familiar with from your bikes, right? With this, we have a few questions about, it says gear train A. And what I want to tell you, right now, the handle is on the big gear. So this is what we're going to call gear train A, where the handle is here. So in the gear train A, is the speed increased, decreased, or constant? And remember, what we're talking about is the speed of the big gear, or sprocket, when it has a chain, they're called sprockets, compared to the little gear, or sprocket. Is this going to speed up, or is it going to slow down, or is it going to stay the same? And we can show you, if you're counting how many times that little gear goes around for every one time our big gear goes around, you'll see if our speed is increased, decreased, or constant. Does the small gear move faster than the big gear at the same rate, or does it move slower? All right, we've talked about this before. We've talked about it in class. You've had some readings on it. In gear train A, is the torque increased, decreased, or constant? So go back to what we've talked about in terms of speed and torque. When speed is increased, what happens to torque? When speed is decreased, what happens to torque? And the last one, in gear train A, what is the input to output ratio, or the gear ratio? We have a 30-tooth input gear. Remember, our handle's here, so this is our input. 30-tooth input gear, 18-tooth output gear. And remember, our formula for gear ratio is output over input, and then we reduce by the greatest common factor and write like a ratio. Now, we're going to do something a little bit different. Now we're going to do what we used to refer to as gear train B. And this is what it means when the next question says, what happens to speed, torque, and gear ratio if the smaller gear becomes the drive gear? So now, this is gear train B. This is the smaller gear. Now, when I turn this one time around, how many times around does the big gear turn? If I turn this, is the small gear moving faster, slower, or are they both moving at the same rate? The small gear now compared to the big gear. All right, and tell me what's going to happen in this situation with speed, torque, and the gear ratio. And the last one, does the input shaft turn in the same or opposite direction of the output shaft? So once again, when we look at this, are those dots moving in the same direction? Are they both moving clockwise, counterclockwise, or are they moving in opposite directions, where one is moving clockwise and one is moving counterclockwise? All right. We have one more to go through, and it's going to be pretty similar to our chain drive, but this time we have a belt and pulley. Now this mechanism we use all over the place. Once again, we'll move the handle up so you can see where the handle is. If you had to use a snowblower this winter, this is the mechanism that makes that snowblower work. All right, it's going to go from the engine to the blade that throws the snow in the front. If you look in the front of a car engine, in order to have the cooling system work and the air conditioning system work and create electricity for the engine, this is the mechanism that's going to turn all those different parts that makes that happen for the car. We're getting into spring. We're going to have to mow the lawn soon. If you have a self-propelled lawnmower, whether it be push or ride on, this is the mechanism that makes those move as well. All right. So with this, we have our handle. This side is the input. All right. So skip over the first one. It says label the drive and driven pulleys. The second one is the speed increased, decreased, or constant. Now, when I turn this, is that second pulley speeding up or slowing down? All right, the belt is turning the other one. Just try to look at that. Remember, these two pulleys are the same size as well. And with that, is the torque increased, decreased, or constant? So once again, think about speed. Was speed increased, decreased, or constant? Remember what we said about torque and speed before in class. After that, what is the input to output ratio? Measure the number of rotations on the driven axle and the drive axle. So what they want you to do is, let's see if we can do this. Get these both set in the same spot. Okay, there we go. So now I'm going to turn it around. All right. How are those turning? Do they look like they're turning at the same speed or a different speed? All right. And how many times does one turn around compared to the other one? Also, think about what we've done so far with gears. If the two gears are the same size, like we calculated before, what are those ratios? All right. After that, does the input shaft turn in the same or opposite direction of the output shaft? Once again, this is the input shaft, this is the output shaft. Are they turning the same direction? Are they both going clockwise or counterclockwise, or is one going clockwise and one going counterclockwise? All right. And the last one, what happens if the belts are crossed? So what we're going to do here is we're going to take this belt and we're going to cross the belt. Now when we turn it, what happens to the direction of those pulleys? All right. So there you go. There's your next three mechanisms. I want to thank you guys that are working hard to keep up with this stuff. Hope everyone has a good day, good weekend, and we'll see you for the last video next time.